We're going to do a few problems here involving negative exponents and some of the rules involving exponents. The first problem here, we need to multiply these two expressions together, and we need to remember our product rule, which says that a to the m times a to the n, where we have the same base, we're going to add our exponents. So we're going to use this rule for this particular problem. We're going to take y to the negative third, and we're going to add 5. When we add negative 3 and 5, you should come up with a positive 2. So your answer there is y equals, or the answer is y to the second. The next problem, we're going to do the same thing. We're going to take x to the negative 3, and we're going to add negative 4. Negative 3 plus negative 4 gives me negative 7. I don't want to leave my answer with a negative exponent. I'm going to use the rule which says a to the negative exponent is the same as 1 over a to a positive exponent. So I'm going to use that rule over here, and I'm going to make this 1 over x to the 7th. The next one, we're going to again use our product rule when we multiply our x's, and then we're going to just regularly multiply our negative 2 and our 8. So we have negative 2 times 8, and then we're going to be multiplying x to the second times x to the negative 6th. Negative 2 times 8, negative 16, and then my x's, I'm going to be adding my exponents, positive 2 and a negative 6. That ends up giving me negative 16x to the negative 4th. I need to rewrite my x to the negative 4th. Notice that the only thing being taken to a negative exponent is the x. The 16 isn't being taken to a negative exponent. It actually has an exponent of positive 1 on it. So what we do is we circle what we need to move. We're going to rewrite it using what we did above. So we have negative 16 times 1 over x to the positive 4th, and that ends up giving us as an answer negative 16 over x to the 4th. This next problem involves the quotient rule, and the quotient rule says that if we have a to the m over a to the n, so again we have the same base, we're going to keep the base and we're going to subtract our exponents. So we're going to do that in this particular problem. We have 4 to the negative 5th, and we're going to subtract 3. That gives us 4 to the negative 8th, and then we need to rewrite this without a negative exponent, and it becomes 1 over v to the 8th. Here we're going to be using our power rule, and our power rule says that if we have a to the m, and then that's being taken to another power, I usually call it a power to a power, then we're going to multiply our exponents. So over here we have a power to a power. We're going to multiply these two things together right here. I'm going to leave the 2x to the negative third outside. When I multiply these two, negative 2 times negative 5 gives me a positive 10. Then I'm going to go ahead and use my product rule. So I have 2x to the negative third plus 10. And then simplifying that gives me 2x to the positive 7th. On this particular problem, notice that it's not 2 that's being taken to any of these exponents, so I don't need to do anything with the 2 except just bring it along for the ride. This particular problem, we're using our power to a power rule. We're going to need to multiply our exponents, so 3 times a negative 3 gives me b to the negative 9th. In the bottom, I'm going to have a negative 2 times 5, that gives me b to the negative 10th. Then I'm going to use my quotient rule, which says that I'm going to subtract my exponents when I have the same base and I'm dividing. And I have a double negative going on here, that becomes a positive. So now I have b to the negative 9 plus 10, which gives me b to the first, which I'm just going to simplify and write as b. Last problem, I have the power rule going on, and I'm going to multiply 4 times negative 3, which gives me a to the negative 12th. And then I need to make sure that I distribute it with the power that I have on b, and the power I have on b is understood to be 1. So 1 times 4 gives me b to the 4th. Then I need to take care of any term or any factor that has a negative exponent, which is just my a to the negative 12th. So I'm going to rewrite that as 1 over a to the positive 12th times b to the 4th. And then combining those together, b to the 4th over a to the 12th.